Welcome NEET 2026 aspirants. Today, we dive into a high-level physics challenge. We have 10 hard and ultra-hard numericals to sharpen your concepts. Let's begin. Question 1, kinematics. A body starts from rest with an acceleration of 2 meters per second squared for 5 seconds. What is its final velocity? Options: A, 5 meters per second. B, 10 meters per second. C, 15 meters per second. Or D, 20 meters per second. Think fast. Here is a hint. Use the first equation of motion. Since it starts from rest, the initial velocity u is 0. Use v equals u plus at. The answer is B, 10 meters per second. Calculation: 0 plus 2 times 5 equals 10. Acceleration multiplied by time gives the change in velocity. Simple yet fundamental. Question 2, work and energy. A force is applied to an object, but the displacement is exactly perpendicular to the force. What is the work done? Remember the formula for work. It involves the cosine of the angle between force and displacement. What happens when that angle is 90 degrees? The work done is 0. Since cosine of 90 is 0, the product of force, displacement, and cosine 90 results in no work performed on the system. Question 3, current electricity. In a standard ohmic conductor, what is the mathematical relationship between voltage V, current I, and resistance R? Think of Ohm's law. It defines how these three pillars of electricity interact. Is it a linear or an inverse relationship? V equals I times R. This means voltage is directly proportional to current for a constant resistance. This is the cornerstone of all circuit analysis. Question 4, modern physics. How do we calculate the energy of a single photon if we know its frequency represented by nu? Planck's constant is the key here. Consider the duality of light and how energy is quantized into specific packets. Energy E equals h times nu. This revolutionary formula shows that higher frequency light, like ultraviolet, carries significantly more energy than lower frequency red light. Question 5, gravitation. Does the acceleration due to gravity, g, increase or decrease as you move higher above the Earth's surface? Why? Consider the inverse square law. As distance from the center of the Earth increases, the pull of gravity must change. Think of altitude effects. G decreases with altitude. The formula is g prime equals g times the square of the ratio of r over r plus h. Gravity weakens further out. Question 6, rotational motion. What is the standard SI unit used to measure angular velocity of a rotating body? Think about how we measure angles in physics. It's not degrees, but a unit based on the radius of a circle. The unit is radians per second. 1 radian is the angle subtended at the center by an arc equal to the radius. Don't confuse it with hertz. Question 7, thermodynamics. If 100 joules of heat is added to a system and the system performs 40 joules of work, find the change in internal energy. Apply the first law of thermodynamics. The energy you give the system must either go into work or increase its internal heat state. Delta U is 60 joules, 100 joules in, 40 joules out as work, leaving 60 joules to increase the internal energy. Energy is always conserved. Question 8, wave motion. What is the fundamental relationship between wave speed v, frequency f, and wavelength lambda? Consider how far a wave travels in one period. Frequency is the inverse of time, and wavelength is the distance of one cycle. V equals f times lambda. Speed is frequency multiplied by wavelength. This applies to everything from sound waves to light waves in a vacuum. Question 9, electrostatics. If the distance between 2 point charges is doubled, by what factor does the electrostatic force between them change? Recall Coulomb's law. The force is proportional to the product of charges, but inversely proportional to the square of the distance. The force becomes 1/4 of its original value. Since it's an inverse square law, doubling distance means to squared, which is 4 in the denominator. Question 10, the photoelectric effect. Which property of incident light determines whether electrons will be emitted from a metal surface or not? Is it the brightness or the color of the light? Think about the threshold frequency required to overcome the work function of the metal. It is the frequency of the light. If the frequency is below the threshold, no electrons are emitted regardless of the light's intensity. Science is amazing. Excellent work today. You've tackled some of the toughest concepts for NEET 2026. Keep practicing, stay curious, and you'll master physics in no time. See you next time.